Well, so some of you may recognize I'm back in Pakistan and I have my other workshop here with the Colchester Student lathe and the homemade lathe. And today I want to try and sort out this problem with the clutch on my Colchester Student Mk1. As you can see, it doesn't disengage properly and it's been a problem for some time. If you've seen some of my earlier videos, you've probably noticed me trying to disengage the clutch before now. I thought I'd try and have a look at this and just see if we can solve the problem. I don't know if I can, but we'll give it a try. So here's the clutch being operated. Now if we look closely at the last plate there, you can see that as it disengages, it does actually pull that plate out. Partly. Yes, it does. It's pulling it out, but even though the last plate is being pulled out of the assembly, it's still not disengaging. So it tends to imply that the other plates are still engaged. Maybe with the machine static, and from this angle you can get a bit better picture of that. You can see that actually the last plate is definitely being pulled out as it disengages. So we know that something seems to be working as it should be, but further inside the assembly it's still not disengaging. Be a 40 thou gap between this splined ring and the last plate. So I've got 40 thou here, and it's a bit difficult to set because the ring rocks, but that looks like about it. Try again. No, that doesn't engage, so that gap is not enough. Quite sure now that it's nothing to do with that adjustment. I've tried it on several settings and I've got it so it feels correct, it feels right. Okay, let's have a closer look at what's happening with the clutch. So as I engage the clutch, pressure is placed on the pack of discs, and okay, let's move in a bit closer because I don't think you can see this properly. Okay, we've zoomed in a bit now, and I think you can see now that the last disc there is actually being pulled away by the mechanism as it should. And what I'll try and do is produce a schematic of what's happening there. So as it pulls away, that part of the clutch is definitely disengaging, but it seems like the remainder of the plates are not somehow. So we're going to have to open this up and take a closer look. What I'm saying here was wrong. When I disassembled the clutch and looked at it more carefully, I realized that actually it wasn't the first plates beginning to separate and the others inside were sticking. No, not at all. Actually, the whole thing was still locked up. It's just that the assembly had a bit of free play in it and the whole assembly together was moving slightly. So it's now time to disassemble and see actually what was happening inside. Well, I've got the clutch plate out and had a closer look at the spline on the drive shaft and also the spline on the drive pulley. Both of them show very little sign of wear, just some polishing as you'd expect after many years of use. But I don't see any grooves or any worn patches there, which might possibly be causing the clutch plates to stick and not release. So I don't think there's any problem with that. What I do see is evidence of grease, which I probably put there when I assembled the thing, when I renovated it 18 months or so ago. And I wonder if that's migrated out and has got between the clutch plates. So what we'll do is we'll go and have a look at the parts I've removed on the bench and have a closer look and see what might have happened. So here are the parts I've removed from the clutch. We've got this nifty little mechanism on the end here which applies pressure to the plates. That's quite clever, and it probably deserves a little closer attention. If I get time, I'll draw a little diagram of how that works. And here you've got the adjusting mechanism. So this is a way of adjusting the pressure on the plates. You saw that in operation when I adjusted it earlier. These rollers are part of this mechanism, and so is this ring. But here we have the plates and the I guess you call them the drive plates. So these are driven from the outside, and these plates take the torque onto the shaft. Now the first thing I notice is they look a bit grubby. You can see that. In fact, they're more than grubby. They've got something actually, and that looks like grease to me. And I think that might well be our problem. Look at that one. Look, very sticky. So there we are. I think we found our problem. I think it's just simply a case of cleaning these up with solvent and reassembling it. And it seems to me that the problem originated because I put some grease on the internal spline when I assembled it, thinking this was metal on metal and that should have a bit of grease in there, but the grease has migrated outwards and has got between this sort of brake material or clutch material, composite material here, and the discs. And look at that, lots of stiction there. Yeah, I think that's our problem. So I'm going to go ahead, clean this, and reassemble. So just as I've cleaned the clutch plates, I'm going to remove all the grease from this spline on the inside here. Hopefully this will cure the problem. We'll see. I'd be interested to know if any of you other Colchester Mark 1.5 or similar lathes with a clutch like this, with a matrix clutch, have had a similar experience. Or was it just silly me who put grease on the spline? Anyway, we'll see. With the parts on the bench and a little time to think about it, I thought it would be a good idea to make a schematic to illustrate how the clutch operates without pressure springs and with a self-locking mechanism. The pulley has two grooves
and it runs on 2 bearings, so that when the clutch is disengaged, the pulley is separate from the drive shaft. The drive shaft takes the output to the gearbox on the left hand side. There's an operating fork and clutch plates. The clutch plates comprise actually 4 metallic discs splined to the shaft. I've only shown 3 in the drawing here, and 3 composite fibre discs splined to the drive pulley. The splines not only transmit power through the clutch, but also ensure alignment of the mechanism on the right hand side. You'll see that in the photographs. There's a pressure plate which provides pressure to the clutch, operated by a roller mechanism. In fact, 3 rollers. I've shown one here.
So here you can see the assembly which provides pressure to the clutch, and you've got these 3 rollers equally spaced, and a ring here which just keeps things in place. It's like a cage, I guess, like you have in a ball bearing. And you'll notice that the rollers are obviously they're in a groove here to stop them from rotating. The spindles on which the rollers operate actually run in a track, and that track moves at an angle like that, which operate on an incline on the back of the pressure plate. And again, you'll see that in a photograph. Also, you have a cone which slides over the top of the rollers and causes them to move inwards. So it moves axially like that over the top of the roller, and what that does is to push the roller inwards. That pushes this assembly forward. Finally, on the right hand side there, you have a grey disc which provides alignment for the rollers, but also a backing for them to operate against, and finally a retaining circlip on the end of the assembly. So we're going to have a closer look now at how the mechanism actually works. On the right hand side we have the selector fork, which moves the cone assembly in orange in the left hand direction. That in turn slides over the top of the 3 rollers, causing them to move inwards. And as they move inwards, the shafts, which are part of the roller assembly, rest on this grey plate, this fixed plate, which causes a wedging action against the tapered side of the pressure plate, and that moves in a left-hand direction. And you can see from the relative lengths and thicknesses of the arrows, I've tried to represent the mechanical advantage that goes through the mechanism, starting with a large movement with a smaller force and ending up with a short distance of travel but significant pressure. So this force in this direction, that isn't the force which operates the clutch. That force merely runs over the top of the rollers, which then move inwards. That's the force which moves the assembly forward. And now we'll see how the mechanism operates. The selector fork is moved to the left. The cone moves the rollers inwards and wedges the pressure plate, which moves left and applies pressure to the clutch assembly. In this position, actually the proportions are very carefully designed so that the tapered portion of the assembly is complete and the roller is actually on the parallel section of that barrel. So that means that it's a self-locking mechanism and it doesn't require any continual force from the selector mechanism. So that actually is free at this stage, and it requires a pull in the outward direction to the right to release the mechanism. And of course the other interesting factor is that because the assembly is actually rotating, the rollers want to move outward because of centrifugal force. So in that way it releases. Anyway, we'll put it back together and we'll see whether cleaning everything has done the trick. Okay, time to reassemble everything. and I remember this when I refurbished the lathe, that this has to be put on in the right place, otherwise these little, what do you call them, lands, I guess, these are like 3 lands, they have to line up with the three rollers. Okay, right, yes, that means I'm going to have to take this off, I think, and rotate that. Yep. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, well, that's convenient. So what we've got to do is we've got to take this assembly off and rotate it until it lines up with one of these lands. So out with the circlip pliers again. So we've got to rotate this whole assembly. Take the rollers out, lest we lose them. So we've got to rotate this whole assembly until it lines up with where this will go. Still not right. Yep, got there. Okay, well that shows you that the adjustment's not right. So what we do is we adjust that until, yeah, now it has this clamping function. Okay, we'll adjust that finally once we get it all back together. Okay, the clutch is reassembled. We're ready to give it a try. Let's see if this has done the trick. Well, that's all we have time for. Great to have finished this little project. Sometimes they're easy, sometimes they're difficult. This was an easy one. That's all I have time for while I'm here in Pakistan. This was just a short visit, but I was glad to be able to do a little bit of work on the Colchester Student. Next time I shall be joining you from the UK, and I hope to continue my series on the M4 pillar drill.